We are going to learn the greedy algorithm. With an example, we are trying to understand the meaning of the greedy algorithm. So, suppose we are going to find out a 35 rupees. Means if I will tell you that give me 35 rupees, then what are the different solutions can be provided for this particular problem? One person can give me 35 1 rupee note, another person can give me 17 2 rupee coin and 1 rupee note. Another person can give me that three 10 rupee notes and five 5 rupee notes. This is our solutions. Now if again I will say that I will not accept all the coins. Means I will not accept 1 rupee coin or 2 rupee coins or 3 coins or many coins. I will accept only these three coins. Means either I will accept a 5 rupee note or 10 rupee note or 20 rupee note. Other than these three I will not accept any other note. Then definitely this will not become my solutions. This one will not become my solution, but this one will become my solutions. So whenever this is nothing but a restriction. Means I will not accept all the all notes. I will accept only the 5 rupee, 10 rupee or 20 rupee notes. So definitely some of the solutions which will actually satisfy the constants and some of the solutions which will not satisfy the constants. This solution is not satisfying the constant. This solution will not satisfy the constant. This one will have these solutions will satisfy this constant because it will have 10 and 5. Other than these three combinations, within the three combinations I will accept the solutions. Some of the solutions which will satisfy the constraints, they are known as the feasible solutions. Those solutions which will not satisfy the constraint, they are not feasible solutions. So this one will become my one solutions. Another solutions can give me this one that 5 into 7, this one will be a feasible solution. This one is the feasible solutions. Means those solutions satisfy the constraint and non-feasible solutions. Now if again I will say that give me that combinations which will have a minimum number of nodes. Now definitely this one is not my solution, neither this one is my solutions. My solution is that all of them are feasible solutions, but my desired solution is that give me that solution which will have minimum number of nodes. So definitely my desired solution is 10 into 1 plus 20 into 1 plus 5 into 1, because within that three nodes it is possible that I can get 35 rupees. Okay, now the desired solutions, the best among the feasible solution, among all the feasible solutions, the best solution is known as the optimal solution. Feasible solution, optimal solution is the best among the feasible solutions. Here in this problem we are trying to minimize the number of nodes, so that is why it is known as a minimization problem. Now in a exam, the intention of the students is to get more marks, so that will become the maximization problem. Now all these things, means solutions, then feasible solutions, then optimal solutions, all these things I will explain with a simple example. Suppose in a class there are 60 students, so all of them are student, that means solution. Now we organize an exam, right? So definitely this exam is nothing but the constraint. So all the students are going to give the exam. Some of them will pass and some of them will not pass. Those students which will actually pass the solutions, they are known as the feasible solutions. Now out of these past students, one student have the maximum marks. That student is known as optimal solutions. So definitely among the feasible solution, which one is the best, it can be the optimal solutions. Now we will understand how greedy algorithm is used to approach it, means how greedy algorithm is used to solve this problem. So what are the problems? I need to make 35 rupees. I will accept only 5 rupee note, 10 rupee note and 20 rupee note. And I need that solution which will give me the minimum number of notes or points. Okay, so how we are going to solve it? So at a particular stage, what are the solutions I will have? Either I can take 5 rupee note, or I can take 10 rupee note, or I can take 20 rupee note. So as I need to make that, I need to find out that solution where the number of notes will be minimum. So definitely I will pick the maximum denominations. So what I will take? 20. That means at this stage, I will find out, these are the options. This is option 1, option 2, option 3. So at a particular stage, out of these 3 options, I will pick up the best among these 3. So which one is the best? 20. So I will go into the next stage. So in the next stage also I can take 5, 10 or 20. But already in the first stage I have taken 20. So how much is remaining? 15. So definitely I will not, my intention is to minimum number of notes. So I will pick the maximum denominations. So if I will pick up this 20, it will not satisfy it, because total I need 35 plus 20 plus 35 is 20 plus 20 is 15. So 20 I cannot take it. This is not become my solution, because it will not satisfy the, within that it will, whatever the common things I need, that will not satisfy it. So what I will do is that I will take the next maximum. So what are the next maximum is 10. Yes, definitely I can take 10, because 20 plus 10 is 35. That is less than this, less than 35. So I can take. So at this stage 2, 3 options are there, out of which I will pick up the best. Then I will move to the stage 3. At step 3 or stage 3, what I will have, again I will take 10, 10 and 20. 5, 10 and 20. Out of these 3, how much is remaining? 5 is remaining. Already 20 plus 10, 30 is taken. So 5 is remaining. So out of these 3 options, I will take the best one. 20 I cannot take it, because maximum denomination, maximum I will take it 5. So 10 I cannot take it. So what will I will take? Definitely 5. So now this one will become my solutions. So what are the greedy algorithm will say that at a particular step, whatever the options that we have, we will pick up the best among these options. That means we will find out the local best options. Then we will move to the next iterations. In the next iteration, we will do the same thing. Whatever the options we have, out of these options, we will pick up the best options. Now, another restriction is that when I will move from iteration 1 to iteration 2, from iteration 2, I cannot go to iteration 1. Means once I go forward, it is not possible that I can go backward. I need to, if I will approach at the second stage, then definitely there is no way through which I can move backward. So definitely this, if I will apply this approach, that means at each and every iteration, whatever the options I will have, I will pick up the best. I will pick up the local best. So this approach will lead to the optimal solutions. But in greedy algorithm, we never say that we can find out the optimal solutions all the time. Give an example. So for this example, we will find out the optimal solution. I will give another example. Suppose there are 3 paths. From A I can go B, C or D. From B, C, D I can go E. So there are that 2, 10, 20, 10. This one is 1. This one is 22. Now what's the problem? The problem will say that I will need to go to the A to E. Now I need to choose that path which will give me the minimum cost. So at this stage I will have, at A I'll have, I am in A. So from A I can go either B or C or D. So I have 3 options. Now I need to minimize the number of cost. So out of these 3 options, which one is the best? Definitely B. So I will go move to the B. Once I have moved to the B, then definitely there is no other options. Only one option is left, that is this. So 2 plus 22 means 24 will give me the solutions, but whereas the original solution is 10 plus 1. The problem is that whenever I will find out all the, at this stage, the stage, whatever the options I will have, I will make a local based solutions. I will pick up the local based options. So maybe the local based options cannot be the global based. Later, if I will see that this one is the base solution, but the actual path is this one, and the problem will occur due to that due to this restriction is that when I move to the B, there is no other way through which I can again go back to the A. Once I move forward, I need to go the forward directions. So in grid algorithm, like, it is possible that maybe there is no guarantee that I will all the time I will get the optimal solution. For some example problems, definitely I will get the optimal solution, but this cannot be guaranteed. So this is one of the feature of grid algorithm. Thank you.